Hello and welcome to my channel. In this video, I am going to discuss the top 15 multiple choice questions on the topic measurement and experimentation. These questions are designed to test your knowledge and stimulate your thinking. To get the maximum benefit of this video, I would recommend that after reading the question, you pause the video, answer the question, and then play the video again to check your answer. So let's get started. Question number 1. A certain physical quantity is defined as distance per unit mass. Which of the following is not possible unit of the physical quantity? So the quantity is distance per unit mass. Now distance can be measured in meter, centimeter or foot, and mass can be measured in kilogram or gram or pound. So if you look at the options, option B, that is gram per centimeter, is not possible unit. Question number 2. Pendulum A has a bob whose mass is 40 gram. So pendulum A has bob whose mass is 40 gram. Effective length 80 centimeter. And it completes 20 oscillations in 30 seconds. The pendulum B has bob of mass 80 gram. Effective length of the pendulum B is 80 centimeter. In how much time will pendulum B will complete 20 oscillations? So we need to find out time for 20 oscillations. Now we know that time period of a simple pendulum depends only on two factors. One is length and second is acceleration due to gravity. And here for both the pendulums, both the factors, that is length and acceleration due to gravity, are same. That means the time period of both the pendulums must be same. And hence both the pendulums will take same time to complete same number of oscillations. So here the answer is option D, 30 seconds. How will air resistance affect the frequency of a simple pendulum? Air resistance affects the time period but not the frequency. Hence the answer is D. The frequency remains the same. Next, question number 4. The effective length of a pendulum is 400 centimeter. What is its approximate time period? Time period can be calculated using T is equal to 2 pi under root L upon G. So that is equal to 2 pi under root, length is 400 centimeter. If we convert that in meter, that is 4 meter. G is 9.8 meter per second square. Now we know that under root 9.8 is approximately equal to pi. So we can cancel them. So on simplifying this, we get 2 into 2, that is 4 seconds. Option C. Question number 5. The effective lengths of two pendulums are 36 and 81 centimeter respectively. What is the ratio of their frequencies? Let us first find the ratio of their time periods. T1 upon T2. That is equal to under root L1 upon L2. That is root 36 upon 81, 6 upon 9, or 2 by 3. But we know that time period is inversely proportional to frequency. So frequency ratio will be 3 by 2. Hence the correct option is option C. 6th, which of the following diagrams illustrates the Vernier principle? The Vernier principle says that 10 Vernier scale divisions is equal to 9 main scale divisions. Okay, this is the Vernier principle. So based on this, if you look at these diagrams, this principle is followed in diagram C. So correct option is option C. Question number 7. In a certain Vernier calipers, the length of each main division is equal to 1 mm. That is nothing but equal to the pitch. So we are given pitch, that is value of one main scale division, 1 millimeter. And there are 20 divisions on the Vernier scale. What is the least count of the instrument? Alright, so least count is pitch upon number of Vernier divisions. That is 1 millimeter upon 20, 0.05 mm. Option D. 8th, in the diagram below, what is the distance between the third 3 centimeter mark and the Vernier 0? So if you carefully observe the diagram, Vernier 0 is between 3.3 and 3.4 centimeter on the main scale. Okay, so our answer is somewhere between 3.3 and 3.4 centimeter. And there is only one such option, option C. But if you want to verify how 3.34 centimeter is the answer, we can follow the procedure. According to the procedure, the main scale reading is 3.3 centimeter. Then we need to identify what is vernier scale reading. Vernier scale reading is division number 4. Vernier division number 4 is coinciding with the main scale. So vernier scale reading will be 4 into least count, that is 0.01 centimeter. So vernier scale reading will be 0.04 centimeter. An addition of MSR and VSR will give us the final answer, 3.34 centimeter. Question number 9. In a certain instrument whose least count is 0.1 millimeter, the vernier 0 is left of the main scale 0 when both the jaws are in contact. At that time, the sixth vernier division coincides with the main scale division. Which of the following is correct? So if you read the options, first we need to identify whether the instrument is having positive error or negative error. If you read the question once again, it is stated that vernier 0 is left of the main scale 0. This indicates that the vernier or the given instrument must be having negative 0 error. So option A and option C are eliminated. Now we need to select between option B and D. So for that, let us identify what is the value of the error. Now here sixth vernier division coincides. So whenever the error is negative, what do? We subtract the coinciding vernier division, that is 6 here, from total number of vernier divisions, which are 10 in general. So 10 minus 6, that is equal to 4. We multiply this number with least count, that is 0.01 centimeter. So the error becomes 0.04 centimeter. All right. So error is minus 0.04 centimeter, or we can say minus 0.4 millimeter. That is indicated in option D. 10th. If MSR is equal to 4.20 centimeter, that is main scale reading, VSR is 0.08 centimeter, vernier scale reading, and positive 0 error is equal to 0.02 centimeter, what is the dimensions of the object held by the vernier jaws? All right. So let us first add MSR and VSR. MSR is 4.20 centimeter, VSR is 0.08 centimeter. So the observed reading becomes 4.28 centimeter. To find out the final answer, we need to adjust the error from this observed value. And the error given here is positive, so the correction must be negative. Hence the final answer is 4.28 minus 0.02, that is 4.26 centimeter. Option B. 11th. For which of the following dimensions is a screw gauge the most suitable instrument? Thickness of a credit card, length of a charging cable, inner diameter of a teacup, or width of a laptop screen? So of course the answer is option A, thickness of a credit card. 12th. A screw gauge has 50 divisions on its circular scale. The thimble of the instrument advances by 1 mm upon 2 complete rotations. What is the pitch of the instrument? So pitch can be defined as linear distance covered, that is 1 millimeter, upon number of rotations, 2. So 0.5 millimeter is the pitch. Option B. Next, 13th. A screw gauge has a pitch of 1 millimeter and 100 divisions on its circular scale. It has a negative 0 error of 0.21 millimeter. Which circular scale division, that is CSD, will align with the reference line when the stud and nut are in contact? So let us first find out what is the least count. That is pitch 1 millimeter upon number of circular scale divisions, 100. So 0.01 millimeter is the least count. Now negative 0 error is given here, that is 0.21 millimeter. So since negative error is 0.21 millimeter, we can say that 21st division is coinciding. But since the error is negative, we must subtract this 21st division from 100. So 100 minus 21, that is 79th division must be coinciding with the reference line. 14th. A screw gauge has a pitch of 0.5 millimeter and 50 divisions on its circular scale. When the stud and the nut are in contact, the circular scale 0 is below the main scale 0 and 6th circular scale division aligns with the reference line. What is the type and magnitude of the 0 error? 0 of the circular scale is below the main scale, that is given in the question. That means the error is positive. So either option A or C is correct. Now it is given that 6th circular scale division aligns with the reference line. So to identify the value of positive 0 error, first let us identify the least count. That is pitch 0.5 mm upon number of divisions on the circular scale, that is 0.01 millimeter. And if we multiply this least count with the circular scale division which is coinciding or which aligns with the reference line, we get 0.06 millimeter. Hence option A is correct. 15th. A screw gauge having a positive 0 error of 0.14 millimeter is used to measure the thickness of a steel sheet. The figure shows the reading on the instrument when the sheet is held between its stud and nut. What is the thickness? So we need to identify the least count first. Least count is pitch, that is 0.5 millimeter. As you can see here in the diagram, the value of one division on the main scale is 0.5. Okay, this is 0.5 millimeter, and this division is 1, then 2, then 3, then 4, and then 5. So between 0 and 1 millimeter, there is one more division. So its value is 0.5 mm. That is a pitch upon number of circular scale divisions that are 50. So this gives us 0.01 millimeter as a least count. Now, if you see the main scale reading, MSR, 5.5 division is visible, and beyond that, we can't see any readings. Beyond that, we can't see any divisions. So MSR is 5.5 millimeter. Circular scale reading, the division number which is aligning with the reference line is 42. So we multiply that with the least count, and our CSR is 0.42 millimeter. If we add these two, we get 5.92 millimeter as the observed reading. And since the positive zero error is mentioned here, 0.14 millimeter, correction is required. So after correction, the answer will be 5.92 minus 0.14. Why are we subtracting? Because error is positive, so correction must be negative. So we get the answer 5.78 millimeter. Hence option D is the correct answer. Please subscribe to my channel and like and share the video. Thank you.